So hello everyone, welcome to lesson 27. There will be two parts of lesson 27. This is the first part, which deals with rational root theorem. So let's talk about what's meant by the rational root theorem. So the technical definition is: given a polynomial function with integer or whole number coefficients, a list of all possible roots can be found by listing the factors of the constant term over the factors of the leading coefficient. So it helps us answer this question. Q66, identify all possible rational roots of f of x, meaning roots that are rational numbers, as in not irrational numbers. Okay, so here's f of x. Here's our polynomial. In this case, it's f of x equals 4x cubed minus 5x squared plus 8x minus 6. And we want to identify all the possible rational roots. So the process will be, first you're going to pick out two numbers that are important for rational root theorem. The first one is the leading coefficient. Remember, that's the coefficient inside the leading term. The leading term is the term that has the highest power of x. So we're going to temporarily call that leading coefficient p. So in the case of our example here, p is going to equal 4. Then we want to look at the constant term, right? That's a term that does not contain the variable. Usually it's at the end, especially if the polynomial is in standard form, but it may not be. And we're going to call that q. And then what we're going to do is we're going to list all the factors of q over all the factors of p. So we're going to make kind of a big fraction here. So usually you can set up a line. And in the numerator, we're going to list all the factors of q, which q we labeled our, is how we labeled our constant term. So that means in the numerator, you're going to list all the factors of the constant term. And in our case, constant term equals 6. So we'll say q equals 6. So we need all the factors of 6, meaning all the numbers that divide evenly into 6. So for instance, we know 1 divides evenly into 6, so we'll start with 1. But positive 1 and negative 1 both divide evenly into 6, because you can multiply negative 1 times negative 6. So we actually mean positive and negative 1. The next number that divides evenly into 6 is positive or negative 2, and then positive negative 3, and then not 4 or not 5, and then positive or negative 6. So these are the factors of q. Q is the constant term, which is in this case is actually negative 6. And there are all these terms here: plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Then underneath that, we're going to list all the factors of the leading coefficient. The leading coefficient, which we call p, is 4. So 4 has the following factors: plus or minus 1, and then plus or minus 2, and then plus or minus 4. Okay, so we've started our setup here. Now what we need to do, because we're asked to find all the possible rational roots, we need to sort of break this up into all the different combinations. And the way we're going to do that is, for each denominator, we're going to divide all the numerators by it. What I mean by that is we're going to take 1 divided by 1, and then 2 divided by 1, and then 3 divided by 1, and then 6 divided by 1. So let me get those out of our way. Whoops. So we're going to say, I'm going to go down here to a new line. We'll say plus or minus 1 over 1. Okay? And then plus or minus 2 over 1. Plus or minus 3 over 1. And then plus or minus 6 over 1. This gets a little bit messy, but you get the idea. Then we're going to do the same thing with all 4 numerators now over the second denominator. So 1 over 2, 2 over 2, 3 over 2, and 6 over 2. So we'll add to this list plus or minus, let me stick with blue, plus or minus 1 over 2, and then plus or minus 2 over 2, and then plus or minus 3 over 2, and then plus or minus 6 over 2, 1, 2, 3, 6 over 2. And finally, we're going to do the same thing now with all 4 numerators divided by the last denominator, which is 4. So we're going to add plus or minus 1 over 4, and then plus or minus 2 over 4, plus or minus 3 over 4, and then plus or minus 6 over 4. Okay, I know it seems tedious. There is some method to this, and it's going to become useful when we do the part 2 exercises for lesson 27. So now we want to refine this list, okay? And you're going to get, when you do this enough, you're going to get where you can refine this pretty quickly as you go. So for example, all these first terms, okay, these are all divided by 1, right? Which means they just simplify to be whatever the numerator is. So this is going to equal plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Okay, now we're going to start looking at this second set of terms here, all divided by 2. And we'll look one at a time. We'll look at the first one. This is plus or minus 1/2. Now, that doesn't reduce at all, right? So plus or minus 1/2 just stays plus or minus 1/2. Okay, but let's look at the next one. The next one is plus or minus 2/2. Well, 2/2 simplifies just to 1, which we already have. We already have plus or minus 1. So plus or minus 2/2 is actually a duplicate. Okay, the next one in line is plus or minus 3/2. That's not a duplicate, and we can't reduce it, so we're going to add that to our list. Okay, then we have plus or minus 6/2. Well, 6/2 reduces to 3, and we already have 3. So we don't have to identify that one again, so that's a duplicate. The next one is plus or minus 1/4. We don't have that one already, so plus or minus 1/4. Okay, the next in line is plus or minus 2/4. Okay, but that reduces to 1/2, which we've already identified. Okay, so plus or minus 2/4 we don't need. The next one is plus or minus 3/4, which is not a duplicate. And then the last one is plus or minus 6/4. Well, 6/4 reduces to 3/2, which we already have, so we don't have to include that one. So I'll actually go back and erase this last thing here. And so we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 numbers shown on our list. Okay, because all of those are plus or minus, we actually have 16 possible rational roots. That means if we ever tried to find the roots of that polynomial, they have to come from this list. Now that seems kind of trivial right now. You might be thinking, well, how is that any good to us? Well, it will come in very handy in the next lesson where we're going to start factoring polynomials. Okay, so let's try one more example together. Here's f of x equals negative x cubed minus 6x squared plus 11x minus 6. Let's go ahead and identify our terms. Our leading coefficient we're going to say is p. Now in this case, it looks like it's going to be a little bit easier. P is equal to -1. We've got a very simple leading coefficient. It's just -1. That's written very poorly. Just a second. So P is equal to -1. Then over here we've got Q is equal to -6. Okay, which is not a bad constant term to start with. Okay, so what we want are the factors of Q over the factors of P and the factors of Q. Q is our constant term. It's a -6. So those would be plus or minus 1, which is a factor of 6, plus or minus 2, plus or minus 3, and then plus or minus 6. Okay? Now our P term is our leading coefficient. That's just -1. Well, -1 just has the factors plus or minus 1. Okay? And so what that means is when we go to expand this, all we're doing is dividing everything by 1. So everything just sort of stays what it is from the numerator, meaning, let's get rid of that, meaning our possible rational roots are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. And then that's the answer. So 8 possible rational roots, all of them integers, which is kind of nice. So try these in the Delta Math practice, and I will talk to you soon. Thank you, guys.